Okay, let's look at the homework 14, problem number 5. Right, we want to find the mass of the solid inside the cone between the plane z equals 1 and z equals 2, and whose density is given here. Right, so this is actually the solid we looked at as an example in class, and I'm gonna just draw a picture and see if we can remember that. Let's see. So here's the y-axis. Let's see, it takes a little long. Y-axis, and here's the z-axis. All right, and so I'm gonna label those. So z-axis here, and y-axis, and we're gonna look at the cross section. All right, so the cone is going to be, if you look at set x equals 0, so x equal to 0, which is the yz plane, then you have equation z squared is equal to y squared. So that's the intersection between the cone and the yz plane, and by taking a square root you can see that this is just a couple of lines, plus or minus y, right? So slope is positive 1 and negative 1. So if you sketch that, it's going to look kind of like this. Like that, right? And then you have another guy which looks kind of like this, right? So so that's the cross, that's the intersection of cone and the yz plane. And so you will see that you can have z, let's see, z equals 1 is probably somewhere around here, so let's put 1 here, and z equals 2 right here, right? Then you would have a plane, so I'm gonna just draw a plane which would look like this, right? And like maybe like this, and like this, and like that, right? And the intersection is going to be a circle, and I'm gonna draw that here. So intersection probably should look something like that, right? Then you cut it with another plane, z equals 2, which is going to be probably up here, right? So I'm going to just go around here and go here, right? And over here, right? Then intersection is going to look like this. It's a larger circle, so it's going to look kind of like that. All right, the solid that we are interested in is this solid right here, so I'm going to just shade it. Whoop, oh, that's not what I want. Right, so it's going to be, so this is the solid, right? And this is the top side, right? And this is the bottom side, so I'm gonna just shade it like maybe like this, right? So that's this is the solid that we are interested in, right? Then remember that we did both cylindrical and spherical. So let's do cylindrical. I think cylindrical was a little simpler, right? So let's set up the mass, let's say m, right? Right, then you're going to have a triple integral, right? So lower bounds and upper bounds are exactly the same as the example we did, right? We just have to have density here, right? Density x squared plus y squared plus z squared to the negative 1, right? This is the same thing as in polar coordinates. So say x squared plus y squared would be r squared, and you have a plus z squared, right, to the -1 power. So it's really 1 over r squared plus z squared, right? So we're going to put a density here, so I'm going to just say over r squared plus z squared. So that would be the density, right? Then the volume element would be r dr d theta dz, right? Then remember that the bounds are r equals 0 to r equals z, right? So that's fixed theta and z. So you go from here to there, and here r equals 0, here r equals z, right? Then we can rotate this around like this to cover the disk. To do that, we can just start from theta equals 0, go all the way around once, right? Then you have to stack all these disks starting from z equals 1 all the way to z equals 2, right? So z equals 1 and z equals 2, right? Then you just need to evaluate this triple integral, right? I'll let you guys finish that up. Right, that's it. I hope that this will get you going.